Today we will talk about stoichiometry. Stoichiometry is the portion in which we couple balanced chemical reactions, reactants and products with the idea of masses, and with the help of Avogadro's number or potentially the number of moles, we can ultimately determine the amount of material that we're going to form in a reaction or the amount of material that we need to start with to carry the reaction forward. Uh, it is of utmost importance that for a chemical reaction you do have balancing coefficients, because it will be via the balancing coefficients of the balanced equation that we will be allowed to switch over from one molecule to another. For instance, we could switch from big A to big B or big C to big D, or any other combination. But this does require that we do have the proper balancing coefficients in place. Now, specifically, the switch over from one molecule to another has to happen when you're in moles, not in grams, not in volumes, but in moles. You have to switch everything to moles before you decide to make a change between one of the species like A towards B or C or D. Alright, so an example that I showed you before during the types of reactions lecture, we balanced the number of carbons, we balanced the number of chlorines, and we're going to do the same thing again. We're going to balance this reaction to ensure that the carbons and hydrogens are first balanced, and then we'll use that to balance the chlorines, right? So we add 4 in front of HCl to balance the hydrogens. We have 8 chlorines altogether, which gives us 8 chlorines as a total. Now, if we do actually use an amount, and I'm going to keep it simple right now, we're going to start with moles. If we start with an amount in moles, 2.3 moles of CH4, you could use that to switch over to anything like Cl2, for instance. And all you have to do is look at the balancing coefficients of the species you start with and the species that you're trying to go to. And that becomes your conversion factor. Namely speaking, for every 1 mole of CH4 that you start with, you also have to start with 4 moles of Cl2. That's what goes into your conversion right here, which allows you to switch over from moles of CH4 to moles of Cl2. Multiplying the numbers together will yield the final value of Cl2. But it is important that you get under the habit of not only writing the units of the number, but writing the species to which those units belong to. Because as you can see here, we're going to be doing a switch over from units of something to units of something else. And if you don't write it down, you might actually get confused along the process. Now, to be thoroughly complete about this, we could actually do the switch over from the 2.3 moles of CH4 to any of the reactants or any of the products in this balanced equation. Case in point, if we want to switch over to CCl4, the coefficients in the balanced equation are 1 and 1, so you will use that as your conversion factor. Or if you're trying to switch over to HCl, the coefficients will be 1 for CH4 and 4 for HCl, and you can see that down here. Upon carrying out the proper calculations, you will see that the moles of CH4 cancel out every single time, and you end up with either moles of Cl2 or moles of CCl4 or moles of HCl. But the key idea right here is that you can switch over from anything. And you don't even need to start with reactants. You could start with products and switch over to reactants or any other combination. But this has to be done when you have moles. If you don't have moles, you will first have to carry out whatever conversion is necessary to get to moles prior to doing the switch.